All right, so the topic of our discussion today is going to be circuits. What is a circuit? Well, a circuit is a complete path that electrons have to flow from a power source, like a battery, through a load, like a light bulb or a motor, and then back to the power source to complete its path. Okay. A complete circuit that is continuous from start, from the battery through the load and then back to the power source is continuous, or is said to have continuity. So I'm going to show you some examples of some circuits. We're going to build one here on the table, and then we're going to talk about circuit faults and what can go wrong in a circuit. All right, so I've got myself a power supply here. Power supply has a positive and negative. This is a 12-volt power supply, so this is going to serve like our battery would in our car. And I've got a light bulb here that we're going to use for a load. Okay, a load is going to be anything that turns electrical energy into another form of energy. So light bulbs turn electrical energy into light, and motors turn electrical energy into motion. Coils can turn electrical energy into an electromagnetic field. Resistors can turn electrical energy into heat. Okay, so for today, we're just going to use our power supply. We're going to use our light bulb as our load. So to make a complete circuit, all I have to do is have a path for the electricity to go from my power supply to my load and then back to the power supply. So I'm going to take a wire and I'm going to go from the power supply right into my load. And I'm going to take another wire and I'm going to go from that load back into the power supply. And we can see that my light bulb turned on already. Okay, so this is a circuit. A circuit is a complete path that electrons have to flow from the power source through the load and then back to the power source. But we're missing a few things. Okay, number one thing we're missing is going to be circuit protection. Okay, every circuit has to have some type of circuit protection device, and in the automobiles we use fuses and we use circuit breakers. Okay, so for today I'm going to be using a fuse. So this is just a wire that I've taken, cut, and put a fuse in there in the middle. Okay, so fuse is going to act as my circuit protection device. So I'm going to take my positive wire and I'm just going to replace it with that wire with the fuse in it. So now the fuse is going to protect from overload, so too much current flow. So if anything happens in the circuit that could cause too much current flow, the fuse will blow and that will protect the circuit. If we did not have a fuse in there and we had something like a short that caused excessive current flow, then we could potentially have a fire, and that would definitely not be good for our vehicles. Okay, so a complete circuit is going to be our power source, our circuit protection, our load, and our return path back to ground. Now on the automobiles, we don't always use a wire to take that return path back to ground. We use the chassis of the vehicle. So we hook the negative side of the battery to the chassis or the frame or the body of the vehicle. And because the body of the vehicle, the frame and the chassis, the engine block are all big pieces of metal, any metal is going to conduct electricity. We can use the big pieces of metal in our car as a ground path. So we just hook our negative side of our battery to the engine block, to the frame, and to the body of the vehicle. And then anywhere we go on the car and we touch one of those large metal pieces, that's going to be connected to the negative side of the battery. That'll be our ground or our return path, so that we don't have to run an individual wire from every single load on the car back to the negative side of the battery. We can just use the chassis or the body of the vehicle to do that for us. Okay. Now you might be noticing that we're missing one thing here. Okay. We have our power supply, we have our circuit protection, we have our load, we have our ground return path. Those are all the parts of a complete circuit. Okay. And this circuit will work perfectly fine with that. The problem is we got no way to turn this off. So if we want to be able to turn the circuit on and off, we need to add a switch. So where would the switch go? Okay, my power supply has a switch in there, but we're going to ignore that one. Okay, we're only going from out of the power supply through the circuit. So if we want to add a switch to this, should I add my switch before the fuse, after the load? Well, the answer is it doesn't matter where we connect our switch. Our switch can literally go anywhere in the circuit. If we break the circuit, the light bulb goes out and current flow stops. When I reconnect the circuit, current flow starts up again, okay? So the switch's job is just to open and close in order to break the circuit so that we can control the circuit and we can turn it on and off when we want to. So to do that, I'm just gonna add an extra wire here in between. And now I can take these two wires and I can touch them together, and that will complete my circuit, okay? But this isn't a very efficient switch. I'm gonna always have to have my hands on both of them. So we're gonna use a switch. We're gonna plug this in. And now I can turn my circuit on and off using my switch. So right now I've got the switch in the power side of the circuit, but I could also take that switch and put it in the ground side of the circuit. It will do the same thing. It doesn't matter which side of the circuit we're on. We're on the ground side of the circuit now. It still controls current flow just like in any other circuit, okay? So we know what a complete circuit is. Now we can talk a little bit about our circuit fault. So what can go wrong inside of a circuit, okay? So there's several things that are considered circuit faults. One would be an open circuit. An open circuit is going to be any circuit that's not complete. So when I turn that switch, technically I'm opening the circuit, but that's what we call a planned open. We want that to be able to open and close to control the current flow in the circuit. If we got a broken wire or a blown fuse, these would be what we consider unplanned opens, okay? So if that wire is disconnected, maybe I have a poor connection in there, connector didn't get seated properly. If the wire gets broken because it's bent too many times, like in our door panel where we open and close the door, eventually if I continue to bend this wire back and forth, it will break, and that would cause an open in the circuit. So an open is going to be any circuit that is not complete or lacks continuity, and therefore the circuit won't work. Okay. The second type of fault that we're going to talk about is going to be a short to power. Okay. Short to power is kind of an uncommon fault. A short to power is going to be a circuit that has power when it's not supposed to. Okay. So for this demonstration, I'm going to put this switch back on the power side of the circuit. Power side coming out, going into my switch, coming from my switch to my light bulb, and then from my light bulb, actually I'll put this on the power side so we make it less confusing. So from the power source, through the fuse, through the switch, into the light bulb, out of the light bulb and back to ground. Now my switch is on the power side of the circuit now. So when I flip this switch, that's taking the power side away from the light bulb, okay? A short to power would happen when this light bulb were getting power when it's not supposed to. So let's say I got another power wire that's run very close to this inside the car. These two become shorted together. Now we've got a short to power, and now I can flip my switch as many times as I want to. The light bulb never goes off, okay? Short to power is kind of an uncommon fault. It is pretty rare for it to happen, but it does happen occasionally, okay? The next type of fault we'll talk about is probably the most common type of fault. The next type of fault is a short to ground. A short to ground is going to be any wire that contacts the ground on the car when it's not supposed to. So a short to ground is also going to be the most common cause of a blown fuse, okay? Because when we have a short to ground, we have a wire that is going directly to ground, not going through the load, and going right back from power to ground. And if I did that, what you would see is you would see the fuse pop here. I'm not actually going to plug that in and pop my fuse, but if it happened in the car, this wire were to rub through on the engine block, where it touches that bare piece of metal that's grounded to the negative cable of the battery, then that would cause a short to ground. That would pop my fuse, okay? So a short to ground is going to be any circuit or any wire that is come into contact with ground in a place that it is not supposed to. This is probably one of the most common ones out there because we got all of these wires inside of our car, around our engine, running down the frame of the car. And we already said that the body of the car, the frame of the car, the engine block of the car are all ground contact points in my automobile anyway. And most of them have some pretty sharp pieces of metal on the corners. So if that piece of wire rubs against a sharp piece of metal, eventually it's going to rub through and it's going to contact the copper conductor inside this wire. Okay. When that happens, then we've got a short to ground. We've bypassed a portion of the circuit before we go back to ground. Current flow can increase and cause my fuse to pop. Okay. And the last fault that we'll talk about is unwanted resistance. Okay. Unwanted resistance or excessive resistance usually comes in the form of corrosion. So we have corrosion on our battery terminals. We have corrosion on a connector where we plug two wires in together. Okay, if I get corrosion in here where those two are supposed to connect together, then that's going to cause kind of like an extra load in the circuit. Okay, the light bulb is supposed to use the voltage in the circuit. Okay, it uses the voltage in the circuit, it turns it into another form of energy. That's where we get our light from. Okay, but if that electrical energy is getting used somewhere else because of an unwanted resistance, that resistance will take away from the light bulb, or take away voltage from the light bulb. So unwanted resistance will cause our lights to be dim. It can cause our motors to run slowly. And then it can cause some weird things with relays and solenoids, but we'll visit those later when we start doing diagnostics. Okay. So we're going to continue making these videos about circuits, about circuit faults, and then we're going to have some diagnostic videos on how to troubleshoot and how to find these faults in the circuit. Okay. But for today, our circuit faults are open. Open is any circuit that is not continuous, that is broken. A short to power. It's going to be a circuit that has power attached to it that is not supposed to have power attached to it. Okay? Light bulbs are turned on when you're turning the switch off. Short to ground is going to be any wire that contacts ground that's not supposed to. So it bypasses a portion of the circuit, sends the current flow back to ground before it's supposed to, and the short to ground is a most likely cause of a blown fuse. Okay. And then unwanted resistance is going to be corrosion in a circuit, and that corrosion in the circuit can cause the voltage to be used in a place where it's not supposed to. Okay. All right. So thanks for watching my video on circuits. We'll see you in the next one.